Hey, morning, guys. Today is last day, well, not last day, day 2 of section 8.2, but last lesson of the week. Sums of arithmetic sequences yet again. Difference is today we're going to be doing a word problem, and that's the rest of your assignment that you'll have to complete. And hey, look at there, you put some stars down there. Your to-do list today, follow this video. I'm going to try to get it done quick. When the video's done, you should be able to complete numbers 5 through 9. There's a couple beastly problems in there, and in our lesson today, there's a couple rough ones. Please do not forget to turn in your 8.1 and 8.2 try on your own by Monday night. Thank you. Those little smiley faces and stars are just a little coaxing of getting this stuff in as soon as you get it done. Appreciate it. Thank you. Mr. Myers will as well. So basically here, we're turning to page 2 of the lesson, and Jill is laying 1 foot by 1 foot tiles that have one gray side and one white side in a room that measures 25 by 25. Okay, she lays a gray tile in the corner of in the center of the room. Excuse me. Next, she lays a right white ring of tiles around the center tile. Then she's laying a ring of gray tiles around the white tile, and then she's going to go white around the gray around the white. She's going to continually build these tiles that are going to make a cute little pattern going out like the little diagram there on the right side does. So we want to determine the pattern in the number of tiles being added to each ring. Did you hear that? Determine the pattern in the number of tiles added to each ring. Okay, so we're looking at how many tiles are added per ring. Okay, as I said that enough times. And what we're going to do is, okay, n is going to obviously represent the number of tiles added in each ring. That's what n is. So we need to think about this. Now, this first one, we just laid this first tile. We just laid that guy in the middle of the room, and then we began our rings. So I can see I'm looking at 1, 2, 3, 4, 5, 6, 7, 8. There's 8 in ring number 1. And then the next one, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And there's 16 in ring number 2. Remember, this is like n equals 1. This is like n equals 2. Because it's tiles added in each ring. So, as I'm coming across here and I think about this, well, the number of tiles added in each ring, well, there's my first one. I'm looking at a sequence. Here's my n equals 1, my n equals 2. If I drew out another ring of white tile around that last gray ring, there's going to be n equals 3. There's going to be 24 tile in that ring. The next ring outside of that's going to be n equals 4. There's going to be 32 in that ring. Okay? Why is that important to know? Well, because we want to write an explicit formula. We're writing an explicit formula to represent the number of tiles added in the nth ring. Well, because when I look at this, I can see, well, I'm going plus 8. I'm going plus 8. I'm going plus 8. So D equals 8. So my rings added to this tile, my nth ring is going to have 8 plus 8 times n minus 1. There's my explicit formula for the number of tiles added in a ring. Okay, well, that wasn't too bad. Determine the number of rings, the number of tile rings that must be added around the center of the tile, or the center tile, to completely fill the room's floor. Well, how big is my room? My room is 25 feet by 25 feet. Oh, what does that mean? Well, tell me. If the room is, whoa, what am I doing there? The room is 25 feet by 25 feet. Determine the number of tile rings that must be added around the center tile to completely fill the room's floor. Well, what does that mean? That means we're kind of thinking a little bit. So if the room is 25 by 25, how many tiles would be in the perimeter ring? So if I know how many tiles are in the outermost ring, okay, that's how my last ring formed. I know what my last term is, and if I know my last term in my perimeter, whoa, didn't want to do that. Hope I didn't screw something up there. I probably did. Yes, I did. Hold on, be back. Okay, so if I know, like I was saying, if I know how many tile are in my outermost or my perimeter ring, that's my A sub n term. That's the last ring I would be putting in the room. Therefore, I could come back to my explicit formula and I could substitute that number in for A sub n and solve for n, and that's going to tell me how many rings I'm going to have in my room. Okay, well, how the heck do I do that? Well, if I have a room that is 25 by 25, and I want to drop all these tile in here, and I'm going to be a little lazy. I'm not going to draw them all in there, but I know I have 25 tile along this side, 25 tile there. Well, I know if I add up this side, I'm going to have 25 tile. If I add up this side, I'm going to have 25 tile. But now, how many do I have here? Remember, I've already counted these corners. So that one's not going to have 25 in it. How many is that one going to have in there? Maybe 23. And this one's going to have 23. So my perimeter ring is going to have, what would that be? That would be 16, 2, 4, 6, 8. There's going to be 96 tile in my perimeter ring. So if I know how many tile, okay, remember we started in this middle one. My room's 25 feet by 25 feet. If I know I have 96 tile in my last ring, all I have to do is set that equal to my explicit formula, and I can solve for n. I don't want to distribute my 8, so I'm just going to subtract this 8 off, and I'm going to have 88 equals 8 times n minus 1, right? Minus 8, minus 8. And then what am I going to do? I think I'm going to divide by 8, and then that's going to come back, and that's going to give me 11 equals n minus 1. So n probs better equal 12. Hey, I'm going to have, there will be 12 rings total. I'm going to have 12 rings total to fill up my whole room. Okay? Hopefully, so I'm going to have 12 rings. Okay? Well, let's think about this. Let's determine the number of tiles needed to cover the floor. Does that have anything to do with the number of rings I'm going to have in there? It really isn't going to have anything to do with that. If I'm thinking about this logically, my room is 25 by 25, right? And each tile is going to be, well, I'll just reveal here, okay? Tough question. Not really. It's pretty simple. The room is 25 feet by 25 feet. That would make the area of the room 625 square feet. Well, think about this. How much does each tile cover? Well, further, if each tile is a foot by a foot, each tile will cover 1 square foot. That means you would need 625 tiles to cover the entire floor. You have to have 625. Well, that wasn't very difficult math, and let's face it, that didn't have anything to do with my sequence and series. But this last one, saddle up, man. This last one's going to be a beast, okay? Jill has only enough money to buy 400 tiles. Man, must be expensive, special tiles. She decides to lay out as many complete rings around the center tile as she can. How many complete rings can Jill lay with 400 tiles? Okay? She doesn't want to lay a half a ring, a quarter ring, a tenth of a ring. They all will be full rings, so that she's just going to, next time she gets more money, she can add on to that ring with some corner tiles here, right? And this would all be white. She's going to, oh, I'm a terrible drawer. And then she's going to add that white ring. Okay? And so forth. You get the idea. And she's going to add that ring. And then she's going to say, if she has enough to make the connect string, she's going to make a full ring. She's not making partial rings. Okay. Quit beating the dead horse here. No? And then of those 400 tile, how many will she use only if she's going to lay complete rings? Because these tilers, they're sold in lot numbers for the color gray, and she wants to make sure each ring has the same color gray in it. And it might be a different sheen of white, okay? So how the heck are we going to figure this out? Well, sounds like we are looking for the sum of the tiles in n rings, because I don't know how many she can lay, but I know she can only purchase 400 tiles. What are you talking about? Well, I know in the end, she can only, I need a pen here. In the end, she has enough to make 400 tiles. That's how many. So that's going to equal how many rings can she make? Well, don't forget, we have one ring for my center tile plus, how are we going to do this? We're looking plus the sum from I equals 1 to n, because I don't know how many there are. And what was my sequence? My sequence was going to be 8 plus 8 times I minus 1. So this little expression right here, okay, that's giving me the sum of tiles in a complete ring. Okay, well, this is what makes this problem a little bit more difficult. So now I'm going to have 400. That's going to equal 1 plus. Well, yesterday we learned how to find this sum. Remember, that sum was found by taking my first ring plus my last ring times the number of rings divided by 2. Okay, well, what is my first ring? Well, my first ring is going to come from putting that lower limit in there. And if I take 1 minus 1 is 0 times 8 is 0 plus 8, okay, well, that's going to make my first ring. My first ring is going to be 8 plus. How many are going to be? That's my a sub 1. A sub 1 equals 8. Well, what is my a sub n? Well, that's taking my last ring, which I don't know, and I'm replacing that inside there. So my last ring, my a sub n, is going to be 8 plus 8 times n minus 1. That's kind of weird. You're right, it is kind of weird, but that's the way it is. So this is going to be, this is my a sub n. Okay, so a sub 1, this is my a sub n. Now, I need to divide. How many rings are there? There's n rings, right? Well, how did I know that? Well, if I take my top limit minus my bottom limit and I add 1, it equals n. I don't know how many there are. But now I have a wonderful, isn't that a nice equation we're going to solve to find n? Ooh. Okay, so we're going to look here, and it's kind of a beast. We're going to use our calculator to get there, but we're going to say this is 1 plus. We'll check it out. I don't need all of these parentheses in here, really, because there's nothing doing there. That last one I did need there, though. I better put him back. So these are like terms. So I'm going to say that 16 plus, I'm going to distribute my 8, 8n minus 8 times n over 2. And this is going to give me 400 equals 1 plus. Well, now I'm taking that away. That's going to give me what? That's going to give me 8 plus 8n times n over 2. Now I'm going to distribute that to get in there, I'm thinking. So that's going to give me 400 equals 1 plus, well, what's 8? What's 8 times n over 2? Well, that's going to be 4n, I do believe. And then what's 8n times n over 2? Well, that's going to be plus 4n squared. So I'm really looking at a quadratic of 4n squared plus 4n plus 1 equals 400. And remember, when we set our quadratics equal to 0, we can use the quadratic formula, or we can try to factor it. I'm thinking this might factor. It's looking kind of beastly, but I'm going to take the shortcut, and I'm going to graph this in Desmos. Be right back. Okay, so what I wanted to do is I'm graphing my 4. Of course, it's Desmos. I can't put 4n squared. I got to put it in terms of x in the coordinate plane. So I'm entering my 4x squared plus 4x minus 399. And what I did was I'm looking for my solutions. Remember, I'm looking for when does this graph equal 0. That's why these two dots here, that's why that guy and that guy are highlighted, because those are my solutions to my equation, negative 10.5 and negative 9.5, because they're such nice, rational, real numbers that would have factored. However, I don't want to waste my time doing that. So we know back here when we solve this, we know n is going to equal either negative 10.5 and n is going to equal 9.5. Now, first and foremost, I can't have a negative number of rings, so my room's not imploding. And second of all, they said full rings. So, like I said, they want full rings. So I'm not making a 9.5, a ring that's 9.5, finished 9.5 the way. So I gotta say this is gonna use 9 full rings is what she can make. Okay, and if she can only make 9 full rings, how many tile, I believe, is the next question, must she purchase to get that, right? Of the 400 tile, how many tile will she use if she only lays complete rings? Well, what is that doing? That is asking you for yet another one. The sum, I'm not even going to make that. They're saying, okay, I'm going to draw that line off there. What do they want us to know? Here's what they want us to know. How many tiles of the 400 is she going to use? Well, she's going to use the one in the center plus her sum from I equals 1 to the 9th ring, because she's only doing 9 complete rings, of 8 plus 8 times I minus 1. So that's the sum we're looking for. Well, that's going to be 1 plus, well, we know this is going to be the first term. Well, if I put I in there for the first one here, I'm going to get 8 plus, how many rings are in the last ring? Now, well, if I put a 9 in there, well, that's going to be 9 minus 1 is 8. 8 times 8 is 64. Times 8 more, that's going to give me 72 times, divided by 2, well, 9 minus 1 plus 1. Right, we know we have 9 rings, so 9. So that's going to be 1 plus, what is that? That's going to give me 80 times 9 over 2. And I don't like calculators, so I'm going to make that a 1. I'm going to make that a 40, because remember that's over 1. So 9 times 40, that's 1 plus 360. So she's going to use 361 tiles to lay the full 9 rings. That means she's not spending money on 400 rings. She's only spending money on 361 rings. Okay? Well, this is really a beefy problem here, this last one. So if you need to watch that again, you watch it again. Otherwise, have a great weekend this weekend, and we will see some of you on Monday and the rest of you on Monday virtually. Have a good day.